Hi guys, welcome to the code review of metadata client and revised metadata service. So I am Udara again. I'm, first of all, I will discuss uh, provide a brief introduction of metadata service. So metadata service is simply a placeholder for meta information of cartridge instances. Like when Stratos boot up
Udara,
instances.
sorry to
Hello.
interrupt you. Can you just share your screen, the presentation? You have a presentation, I believe.
Okay.
We can't see it at the moment.
I hope now you can see it.
Okay, we can see.
Okay. Uh, I will. Metadata service is stores meta information about cartridge instances. So other interest parties can retrieve the data. They retrieve the data. So metadata service is a central place where some cartridges publish data, so other interest parties can fetch the data. So it is like so the main use case of metadata services comes with the grouping or composite application. So for instance, when we deploy a composite application, uh, a composite application has is a collection of cartridges. So when we deploy composite application, multiple cartridges or multiple instances are boot up. So there came the requirement of information sharing with among those cartridge instances. So this is the main requirement for metadata service. So in the metadata service, we store the data as key value pairs. It is very similar to registry. So it has key and value, one or multiple values. So we have in the metadata service we have exposed several APIs to add metadata and fetch and delete those metadata. So someone can uh, invoke the REST APIs and uh, add or delete those meta information. So this is an example. So here those data are published by MySQL. So here I think hope you can see it. Under MySQL there are multiple properties are published. MySQL IP and MySQL password and MySQL username. So likewise when there are like when there are multiple cartridges, so all the instances publishes their details to the metadata service. All are stored as key value pairs. Here I will describe the usage with the sample use case. Here assume that someone wants to have a LAMP stack with Apache Stratos. So he should deploy uh, an application which has PHP and MySQL. So imagine now with the grouping, we first start the MySQL instance, and then uh, we should start the Stratos starts the PHP instance. So when the PHP instance is starting up, the MySQL is already activated. So now we have PHP and MySQL, but the what missing is if someone wants to create a PHP app which need the need to connect to MySQL. So he has the PHP environment and he has the MySQL database. But the problem is there is no mechanism. There wasn't a mechanism to PHP application developers to get those MySQL connection details. So earlier what we did was we get the MySQL instance details via REST API or CLI or UI. Then we hard code those parameters in the PHP application when creating the database. Uh, so there involves a manual process. So that's the gap. So metadata service came to bridge the gap uh, that I mentioned. So now we have PHP instance and MySQL instance and metadata service. So what happens is when the MySQL instance boot up, uh, its cartridge agent start. So in the instance activated event, we have an instance activated extension point. So so there I have written a Python script to publish those MySQL connection properties such as the IP of the machine and the MySQL username and the MySQL password to the metadata service using metadata service REST API. So here I send a post request to the and I should mention that this application ID, which is test app, is an ID generated for the application, so it is not important here. So and the alias we provide when subscribing to the MySQL. So then all the details are published to the metadata service as properties. So as I showed in the earlier UI how those details are stored. So when the PHP application, when the MySQL gets activated, then the PHP instance gets boot up. So in the instance activated extension point, unlike MySQL, the PHP instance fetches those details by sending the MySQL alias. So it gets all the MySQL host and username and password metadata, and the extension point X add those details as uh, environmental variable. So within the PHP application, a user can using the get env PHP method, he can fetches all those connection parameters. So a user who deploys a LAMP stack or LAMP application doesn't need to know what is the IP of the MySQL, what is the username and password. What he want to know is like he can all fetch those details via environmental variables. He doesn't have to worry about how they are set and how they are fetched. All are done by the cartridge agent. So this is a simple uh, scenario. So when the situation get complex, the cartridge agent should be extended in a way that those how those details fetched and how to set those details. So that is a metadata service. So unlike other than instances, there may be places like status manager, status core components such as cloud controller, autoscaler, or other parties uh, deal with this metadata service. So like let's say for instance yeah, other than the username, password and IP, there may be situation where some let's say git URL or repository URL should be uh, added to the metadata table. So those details are in the cloud controller. So there should be a way that uh, cloud controller core components or maybe any other third party component interact with this metadata service. So in order to do that, we have I have implemented metadata client. It is uh, like it is a Java API to talk with metadata service API. So it wraps REST client. So any other the component which uses this metadata client do all the operations related to metadata like add, get, delete, and other operation using those API. So I will show metadata client and metadata service.
Udara,
So before going to the code level, do you have any questions regarding the design of?
yes, Udara, one question. Can you go to your first slide?
Okay. Yeah.
The second one, actually, one which had the diagram.
This one.
No, this is the one. So
Okay.
the MySQL would publish its properties. What would happen
Yes.
if the MySQL instance is to respawn, terminate and get respawn?
Yeah. So at that point, let's say another MySQL instance get spin up by autoscaler. So it's then it will when the new MySQL instance spin up, it will publish its its details to the metadata service with the same alias because with the here in the alias is my MySQL. So the next newest MySQL instance will also publishes the same details. So here it will override with the default implementation. It will override because that is what we that it is what was a requirement. So there may be a situation like uh, a PHP app needed multiple MySQL instances. So in that case, uh, those details may be not override. It may should be concat, or maybe MySQL host should have multiple IPs.
Okay,
Likewise, then it should like uh, add to add to the current details.
okay, Udara.
So
So what will happen to the currently running PHP
another
instance?
way is, sorry.
What will happen to the currently running PHP instance now? It has the old MySQL instances IP, so it should get updated, right?
Yes.
Uh, so uh, is that particular way to
The,
do that? So
uh, so so with the current implementation, with the current workflow, I think uh, it won't be able to do the requirement you said now. So in
okay,
that case, like
that
there
is
should be some.
yeah, that is fine. Now
Yeah.
since we have you have a metadata client as well, so maybe we
Yeah.
can detect that this particular instance has gone down and then maybe trigger
Yes.
some notification to the PHP instance that it should get
Yeah.
updated itself. Yeah, okay, that's fine.
Yeah.
Go ahead.
Yeah. Okay. I hope you can see the code now.
Yes, Sudhar, we can see it.
Okay. Here I saw I will explain the set of metadata. This is a metadata service. So here uh, we have down we have uh, add properties. So a property is when sending when posting or publishing a property, we have the send the application ID and the cluster ID. Like application ID is and both are sent in the uh, as payload. So so within the so application ID is the ID generated for when we deploy an application, and a cluster ID is it is uh, the same as the alias when we provided to when we subscribe into the uh, when we subscribe into the instance. So here what we publish is the property that it has key and it should have multiple values. So like uh, here here a key is a string and it can have one or more values. Like let's say for in the IP scenario it has only one value. There may be cases with single key has multiple values, so it is also supported. So if I go more deep, uh, here
Udara, one like comment that I have is like it would be better if we stick to the standard like column length, because some of these parameter like method signatures go beyond that, it seems. So like it's in a single screen it's difficult view as you may see.
yeah in the here I have increased the font size to better view the code. So
Okay.
yeah, it is a better version. Okay,
But
I will reformat the code.
Great.
it's I don't think it's about the font size, right? Uh,
Yeah,
Yeah, we can do the formatting. Yes, go ahead,
yeah, yeah,
Udara.
yeah. I think we Sajid is doing the code style for idea and other uh, IDs, so then it will be easy when after the styling is done, completed. So other thing is it can have it can add one property and multiple properties. Here it add an array of properties. The other thing is the get APIs, so it can get all the properties of an application, and it can again get only the property specified. So he can property specify the property name, then it will fetch only the uh, mentioned property. So this is the uh, metadata service. Like metadata service earlier it was uh, having different method of for deploying depending on the cartridge, but here only all the cartridges send their details as key value pairs. So then it will be easy uh, for someone to fetch, because it coming every time it coming the same format. So do you have any suggestion regarding the metadata admin? So I need to go deep. Hello. Okay. The other the other part is the client part. So here in the metadata client component, uh, I have default metadata service client, and it
Udara, again, sorry to interrupt you. Can you just, yeah, that's better. Yes, thanks.
okay. Uh, I have metadata service client which implements the metadata service client. I have interface, so it defines the method which should be in a metadata service client. So like add properties and get properties and get properties. So there should be some other method like deleting properties, so which are not currently yet implemented. So any client which implement which interacts with the metadata service should implement this interface. So here the default metadata service client has uh, when it is starting, so we have a configuration file called metadata service file. So here uh, here this is an example of metadata service client. Here you give the registry type. So by default it is carbon registry type, and other thing most valuable uh, information is the metadata service URL. So uh, so Stratos comes with the default metadata default metadata service which is running on the 94434 port. So another thing is username and password for authentication. So currently with the current implementation, the client or instances PHP or MySQL instance talk to the metadata service with the username and password. So with the password, username and password should be currently it is hard coded, but it is not very safe because the best method is to use OAuth or some many other authentication mechanism. But with the first phase, we thought of using the default username and password. So it reads within the constructor, it reads the uh, base URL and username and password, and create a default REST client. So a default REST client, we have another interface called REST client, which uh, should have do post and do get and do delete and other REST methods. So with the default REST client, I am with the default implementation, I am using the default REST client. So uh, here I uses SSL builder to avoid SSL authentication, and I use a HTTP connection manager. Like in the default one, I use uh, pooling HTTP client manager. Uh, so what is the purpose of using an client manager is without using an client manager with the normal HTTP get and uh, post method only allows two concurrent requests. So that is not the like it won't be uh, sufficient for a production environment. So that's why Apache has implemented multiple connection managers. So I have used here pooling connection manager. It's what it does is it keeps a pool of connections and reuse the same connection when a request is done. So we can set maximum connections and Uh, Another thing is it use persistent connection for a route. A route means a host. So let's say we are using this REST client for sending request for let's say host X, host X. Then we can define multiple the max number of connection for host X. For another host Y, we can again define maximum of default connection number. So it will let's say we provide the default connection for route as 10. Then for every for host X, then it will reuse the same connection every time when it create the connection to the host. So that is why I use the this connection manager. And the other thing are as normal. And the what do post does is it create a HTTP post, and we can send an object as uh, the message body. Like here it will get the object, and it will generate the JSON representation of the object, and it will add to the payload. So that is the implementation of the default REST client. So this this REST client like can be used for any REST invocations, like for any do get and post or any other implementation, any other requirement. So yeah,
So, Udara,
hello, hello.
as I understand, so this default REST client is like bound to JSON, is it?
Yes, yeah.
And
Yes, with the here the content type is sorry, content type is JSON.
okay, right. One
Okay.
general comment that we might need to add some class level comments as well for each class, saying that very simply what the class does. And one another comment, can you please go to the default metadata service client class? Okay, so here in your methods, say add property to cluster and get property, these things you throw metadata service client exception, and in your like constructor you throw REST client exception. That is like a bit inconsistent. So as I understand, the REST client is the level below this metadata service client. So actually, what ideally we should do is to throw this like same exception.
Mm.
We should not
Okay.
expose the REST client exception here.
So what you suggest is to wrap the REST client exception with the metadata service metadata service client exception.
Yeah, some way or the other, we should throw like the consistent exception from this class, because this is the metadata service client.
Okay. Okay. Thank you, sir. So
Udara,
hello.
Udara, can you hear me?
Hello. Yeah, I can hear you.
Udara, how we delete the data from the metadata? Actually, we are using the listener, so we have introduced new REST call to delete the data.
Yeah. So the uh, the place we want to delete the metadata is like, let's say when we undeploy an
Yeah, and deploy the application.
application.
Yeah,
So like then yeah, we have two methods of doing this. Like the first thing is we can have a uh, like topology listener, and when an
yeah,
application
yeah.
is
Complete. Yeah,
removed, even
literally.
receives, we remove the all the resources.
Yeah,
So it is possible, but the problem is then we increase the complexity of the metadata service. So because the idea of having a metadata service is like a static way of storing metadata. So if we are to incorporate topology listeners, and so in my opinion, we will add the extra complexity to the metadata service. So what the other option is, like when the application is removed, CC can use the metadata client and delete the all the resources metadata for that application. So I think autoscaler cloud controller deleting the uh, metadata is the best option in my opinion. Again, you got the answer.
but but again, then we have to expose the new rest method for that.
Yes, yeah,
Is it?
that's why that is the main use case of metadata client. So uh, with the current implementation, I haven't implemented all the method. They have get and post, so we can add the delete method and do the call that API using the in within the cloud controller or uh, autoscale.
Yes. So thanks.
Okay. So
Hi, Udara.
hello, hi, hello, go on, Sajid.
Udara, I think, as I remember, we in a mail thread we said, like, we discussed like having a REST client command which can be used like have developing a REST client as a common component, like kind of thing, right?
Yeah,
Is that so? Have you developed this component
yeah,
in such a way, or are we supposed to reuse the, like if we have requirement in our other code we have where you can use a REST client, can we use this component or?
yeah. Because this REST client can be used for any like RESTful thing. So
Yeah,
this
but the thing is like this. uh
metadata service client is one use of, like, it
right,
uses this
then just for metadata, okay.
yeah,
But
then it
if
it
we go
only
to,
used
but
for this
the
metadata.
REST client, but as I see, this REST client is also in the Apache Stratos metadata client component, right?
Yeah, REST, yeah, yes,
So if you are to reuse the REST client, we need to import this. We need to have this metadata client component as a dependency, right?
No, I think like the best way would be to refactor this REST client as a
yeah,
separate component, and
Yeah,
then yeah,
yeah,
my point is like, yeah, I
yeah.
think
So
yeah,
REST client we can only have before REST client. So
yeah.
metadata service client maybe move to another component or maybe the
yeah.
component.
I think
If
the
yeah,
yeah,
Sajid, go ahead.
yeah, I think REST client should move to some other component, right? I mean, like
Yes, yes, yes,
metadata client should be in the metadata component. Like
yes,
we
yes,
can create a common component, and we can. Okay,
yes.
thanks for that.
Okay. So as a general question, like which Gayan asked, so which is not yet discussed, like what should be the best method of like deleting the resources? Is it adding a topology receiver to the metadata service, or done by Stratos core components, like maybe Autoscale or CC?
This is my opinion, but in my opinion, we should not add dependency on the topology. Service. Sorry, the topology, because we might need to migrate this metadata service, say for an example in future to etcd. Then if we have a dependency on the metadata or the topology, if you have dependency on the topology, we might find it a bit difficult. So if you have a separate REST endpoint to delete data, that is the best option in my view.
Yeah, that's exactly the my opinion also. It is adding extra complexity to the metadata service. So that is pretty much it. Do you have any other question? Okay. Since there are no more questions, I will wrap up the thing. So uh, today I discussed about the metadata service uh, we, and the metadata service client. So I hope you will get a better understanding about those two components. And so I will uh, I am thanking Paul who joined the hangout, and who Isro, Sajid, and Ryan and other who made valuable comments. So I will like refactor and add the suggested changes. So thank you very much for joining the hangout.
Thank you very much, Udara, for the informative session. And one another small thing, it would be better if you share the suggestions which came up in the dev list as well.
Okay.
Thank you very much, Udara.